So in this particular case on the top of page 20, they are giving you the velocity graph. So they're giving you the v of t. So the way they also look at trying to figure out when given a graph what's happening with the speed is if you look in this interval from 0 to a, notice your velocity is negative, acceleration is negative, so your speed should be increasing. So if you start reading your graph from left to right, when you're approaching your interval from 0 to a, what's happening with the length of these line segments? The length of these line segments are getting longer. So that's how you can read the graph knowing that the speed is also increasing because the length of those line segments are increasing from the x-axis. Now notice what happens from A to B when we read the graph. The velocity is negative, but the acceleration is positive. So notice what happens. We know that the speed is decreasing. Notice what's happening with these line segments from A to B. The line segments are getting shorter. So that's what they mean by those line segments getting longer or getting shorter. That's another way, again, given the graph of the velocity, how you can also interpret whether or not your speed is increasing or decreasing. All right, so let's just kind of do a summary of some of these graphs. So now remember, S of t is my position function. S prime of t is your velocity function. And when you're reading a graph, that's where you're looking to see if you're increasing or decreasing. The second derivative is the acceleration. And that's where you're looking at the concavity in order to figure out the sign of acceleration. So again, to figure out the sign of acceleration, you're looking at the concavity of the curve. If you're given the position curve, you're looking at, when you're looking at the position curve, you're looking at increasing or decreasing to determine what's happening with the velocity. All right, so let's take a look at time t is equal to 0. So again, S of t is 0. The position is on the positive side of the origin, so you know the particle is on the positive side of the origin. The curve has a positive slope. So if your curve has a positive, oh, I'm filling in the wrong place. The curve has a positive slope. That means your v of t is going to be greater than 0. And again, what that means is your particle is moving in the positive direction. The curve is concave down. So if your curve is concave down, that means your a of t is less than 0. So again, what this means is that since your v of t is greater than 0 and a of t is less than 0, that means your particle is slowing down. So that makes sense to everybody when you're looking at, again, you're looking at your position versus time curve. So you're given the position curve versus the time curve. How you can tell the acceleration and the velocity. Looking at the second one, the position is still greater than 0 because, again, notice you're still on the positive side of the origin. However, notice your curve has a negative slope. It's decreasing. So that tells me that my v of t is less than 0. So what that means is the particle is moving in the negative direction. Notice your curve is concave down. So since my curve is concave down, that means my acceleration is also less than 0. So that means my velocity is decreasing. So since a of t is less than 0 and v of t is less than 0, and since acceleration and velocity are the same sign, I know that the particle is speeding up. So now if you take a look at the position of the particle at time c is 0 in this third example, notice I'm on the negative side of the x-axis. So s of t sub 0 is less than 0. The particle is on the negative side of the origin. The curve has a negative slope, so my v of t is less than 0. Again, notice my function is decreasing. So that tells me the particle is moving in the negative direction. And notice the curve is concave up. So my a of t is greater than 0. So this means that my velocity is increasing. So since my a of t is greater than 0 and v of t is less than 0, the particle is slowing down, because acceleration and velocity are different signs. Now, there is a moment where, again, I'm going to have a zero slope. The position is still positive. I'm on the positive side of the origin. But when you have a zero slope, the particle is momentarily stopped. So this is when your v of t is equal to 0. Notice my curve is concave down, which means that a of t is less than 0. So what this means is the particle is neither speeding up or slowing down, because your velocity is equal to 0. So any questions on how you can interpret a position curve in terms of velocity or acceleration? All right, I'll see you guys after lunch. Speed. So just a reminder, so when we're talking about the sign of acceleration, when you're dealing with a particle in rectilinear motion, an object is speeding up when the velocity and acceleration have the same sign, and it's slowing down when they have opposite signs. So notice I'm giving you the graph. Always pay attention, just like we did earlier. What graph are they giving you? They're giving you the graph of the position function s of t. Determine the time interval at when the particle is speeding up and when it's slowing down. So if you take a look at this particular interval from 0 to 2. So let's take a look at that time interval from 0 to 2. Let's talk about v of t. So now remember, to determine when you're given the position curve, to determine the velocity, you're looking for increasing or decreasing. So what's happening with my velocity from 0 to 2? Is it greater than 0 or less than 0? Greater than 0. Now let's look at the acceleration. Remember, the acceleration, you're looking at the concavity. Are we concave up or concave down? Up. So my a of t is greater than 0. So then what's happening from 0 to 2? Is this object going to be speeding up, or is it going to be slowing down? Speeding up. All right, so now let's look from that time interval from 2 to 4. So now from 2 to 4, tell me about your velocity. Velocity is what? I'm looking at increasing or decreasing, so what's happening with velocity? It's going to be what? Greater than 0, because it's increasing. Now for my acceleration, I have to look at the concavity. Am I concave up or concave down from 2 to 4? Down. So then my acceleration is going to be less than 0. So since velocity is greater than 0, acceleration is less than 0, is this object going to be speeding up or slowing down? Slowing down. All right. So now let's look from 4 to about, I think this is about probably 6.5 maybe. So tell me about my velocity. My velocity is going to be less than 0 because I'm decreasing, correct? Then my acceleration, negative because I'm still concave down. So again, because velocity and acceleration are less than 0, this object is going to be speeding up. And then finally from about 6.5 to 10. What's happening with my velocity there? It's constant. So my velocity is what? V of t is actually what? Equal to 0. So is this object going to be speeding up or slowing down, or neither here? Neither. So any questions, ladies and gentlemen, when you are given the graph of the position function, how you can determine whether or not an object is speeding up or slowing down when you look at the velocity or the acceleration? Okay? Some other things we're going to talk about is displacement. And remember, that's the change in position of a particle over time. Remember, displacement can be positive, it can be negative, or it can be 0. displacement be 0? If you have an object that starts right here at the starting point and it travels, and you end up exactly at the same location as where you started, that's when you can end up with a displacement of 0. But when we talk about total distance traveled, in a time interval, distance is always positive. So even when the particle is moving in the negative direction, the distance is positive. We'll take the absolute value in those particular intervals. So in this particular case, notice, even though I'm starting and ending in exactly the same spot, the total distance traveled would not be equal to 0. All right? So here's the steps to find the total distance. First of all, what you need to do is you need to find where your velocity is 0. So again, remember, this is where, just like what we've been doing, you take your s prime of t and set it equal to 0. You're going to separate the intervals into positive and negative velocity. Calculate the distance traveled in each interval by substituting into your position function. Again, remember, your position function is your s of t. Now, what you're going to have to do is you have to take the absolute value of the intervals where you have negative velocity. So again, we know where s prime of t is equal to 0. We've done the number line test. So any of those intervals that have a negative velocity, we'll have to take the absolute value when we're trying to calculate total distance. Add up the distance from each interval to get the total distance. And remember, total distance traveled is always positive. So we looked at a graph. Now let's take a look at a function in example 4. So given the position function, so again, we're given s of t, we wanted to determine the time interval where the particle is speeding up and slowing down. So we did it graphically when given the position function, so now we're going to do it algebraically. So for part A, first of all, what we have to do is we have to find where is the velocity, positive or negative. So again, I'm going to find my velocity function by taking the first derivative of the position function. So I end up with 9t squared minus 18 times 2 is 36t. So I'm going to set this function equal to 0. So 0 is equal, and I'm going to go ahead and factor out a 9t, so that's going to give me a t minus 4. So then I end up with t is equal to 0 and 4. Now remember, I'm looking at a time interval where t is greater than or equal to 0. So on my number line test for my velocity, again, I'm starting at 0, and the one critical value is going to be 4 that I'm going to plot on the number line. So again, to figure out whether velocity is positive or negative, I'm going to plug in a number between 0 and 4, so I'll plug in a 1. So when I plug 1 into my velocity function, I end up with a negative. When I plug in a 5, I end up with a positive. So any questions on finding where velocity is positive or negative? So now I need to find where acceleration is positive or negative, so I'm going to have to take the derivative of the velocity function, which is the second derivative of the position function. So let's see, when I take the derivative of 9t squared, that's going to give me 18t minus 36. Set my acceleration equal to 0, so 0 is equal to 18. I'll factor out that 18. So then I end up with t is equal to 2. So then when I go to do my number line for my acceleration, again, my time interval is when t is greater than or equal to 0. So I'll plot 2 on my number line. So when I plug 1 into my acceleration function, I end up with a negative. When I plug in a 3 into my acceleration, that gives me a positive. So any questions on finding where acceleration and velocity are positive and negative? So now I need to figure out where I am speeding up. So now remember, I'm speeding up where acceleration and velocity are the same sign. So where is my acceleration and velocity the same sign? Well, they're both negative from 0 to 2, correct? So I know that I'm going to be speeding up from 0 to 2. Anywhere else? 4 to infinity. So now where am I slowing down? So from 2 to 4, notice velocity is negative, but my acceleration is positive. So I know I'm going to be slowing down from t is equal to 2 to 4. So any questions algebraically how you can determine when you're speeding up or slowing down? All right, so now let's take a look at part B. So for part B, they want to know, find the total distance traveled from t is equal to 0 to t is equal to 6. So remember, what you have to do is you have to consider where the velocity is negative, and you're going to have to take the absolute value. So to calculate your total distance traveled, we're going to have to take the position function, but take the absolute value of s of 4 minus s of 0. And what's going to happen is I'm going to add that to s of 6 minus s of 0. S of 4, excuse me, not 0, 4. So now what you want to do is I want to just simply take 4 and plug it back into my position function. So when I plug 4 back into my position function, I'm going to go ahead and use my calculator. 3 times 4 to the third. And then minus 18 times 4 squared. I get negative 96. Minus, when I plug 0 back into my position function, that gives me a 0. Plus, now I'm going to plug 6 back into my position function, so 3 times 6 to the third. Minus 18 times 36. That gives me 0. And I already know what s of 4 is. S of 4 gave me a negative 96. So then I simply will add 96 plus 96 together, and that's going to give me 192 for my total distance. So any questions on part B? And then to find part C, my total displacement, all I'm going to do to find part C is I'm going to take the change in position at time t is equal to 6 minus s of 0. Well, we already know that s of 6 is 0, so 0 minus 0 is just going to give me 0. And remember, displacement, what that tells you is you ended up exactly at the same place as you started. All right, and you get a displacement of 0. So any questions on how you can calculate your total distance or your displacement? Good on that? All right, one last thing. Finding maximum and minimum speed. So remember, speed is the absolute value of the velocity function. So when we talk about speed, speed is going to be equal to the absolute value of your velocity. So since I want to maximize or minimize speed, what you want to do is obviously you're going to have to take the derivative of the speed function. Just like what you've been doing, you want to find your critical points. So take the derivative of the speed function, set it equal to 0. And then what we're going to do is, again, we're going to substitute it back into your speed function. Again, we're trying to find your extreme values, or your absolute maxes and mins. The largest value is your maximum speed, and the smallest value is the minimum speed. So they're giving me, notice the position function, and again we want to first of all find the maximum speed of the particle from 0 to 4. So again, you're dealing with maximums over a closed interval. So your candidates are not just going to be where the derivative of the speed function is equal to 0, but it also can occur at the endpoints, remember. So the candidates will be those critical points as well as 0 and 4 when we're talking about where maximum speed is going to occur. So first of all, my position function is 100 over t squared plus 12. So I want to find s prime of t, because the speed function is going to be the absolute value of the velocity function. And remember, the velocity function is the first derivative of the position function. How am I going to take the derivative of 100 over t squared plus 12? Do I have to use quotient rule on this? No. Remember, I can write this as 100 times t squared plus 12 to the negative first. So when I take the derivative, I'm going to have to apply my chain rule. So I'll end up with negative 100 times t squared plus 12 to the negative second times 2t. So then my velocity function is going to be negative 200t over t squared plus 12 to the second. So there's my velocity function. So then to find my speed function, remember, speed is equal to the absolute value of the velocity function. So when I take the absolute value of negative 200t over t squared plus 12 to the second, well, no matter what value I plug in for t, because I'm squaring that denominator is always going to be positive. So what sign can I eliminate from the velocity function to give me the speed function? That's simply going to be what? 200t over t squared plus 12 squared. So there is your speed function. And I'm just going to box that in because, remember, that's what I'm trying to maximize or minimize. So any questions on how I found the speed function? So now remember, what I'm going to have to do to find the maximum, I'm trying to maximize and minimize speed. So just like when you're trying to do maximum and minimums, you're going to have to take the derivative of the speed function. So I have to take the derivative of 200t, and I'm just going to write this as a t squared plus 12 to the negative second. It's probably an eeny, meeny, miny, mo. It's probably just as easier to leave it as a quotient and just use your quotient rule versus using your product rule. Either one would work. I'm going to go ahead and just leave it alone. I should have just left it alone. I'm going to use my quotient rule. All right? So then to find the absolute value of the velocity function, I'm just going to use my quotient rule. F prime g minus f times g prime. So when I take the derivative of t squared plus 12 to the second, that's going to be 2 times t squared plus 12 times a 2t, all over the denominator squared. Isn't that a fun function? So any questions on how I did the quotient rule? So now, when I'm looking at simplifying this, before I do any distributing or anything like that, what I would look for is there a greatest common factor I can factor out of the numerator? So look at this numerator. What is a GCF I can yank out of all this? I can yank out a what? 200. And what else? T squared plus 12. So let me yank that out. So when I yank out a 200 and a t squared plus 12, I'm going to be left with a t squared plus 12 from that first term. The 200 is yanked out. The t squared plus 12 is yanked out. So that's going to leave me with a minus what? That's going to leave me with a minus, so that's 2 times 2 of 4t squared. All over that denominator. So any questions on what that numerator looks like after I factor out that greatest common factor? So now what are you going to be able to cancel out? You're going to be able to cancel out a what? T squared plus 12. And I can simplify what's on the inside. That's going to give me a 200 times negative 3t squared plus 12 all over a t squared plus 12 to the third power. So now remember, what I need to do is I need to find my critical points. Do I have to worry about setting this denominator equal to 0? Because what ends up happening when I try to set this denominator equal to 0, I end up with imaginaries, don't I? So what I just need to do is take this negative 3t squared plus 12, set it equal to 0. So I can subtract my 12. And then divide by a negative 3, so t squared is going to be equal to 4. So what's t going to be equal to? Plus or minus 2. But remember, what's my interval I'm looking at? I'm only looking from what? 0 to 4. So I can eliminate negative 2. So now remember, we talked about we're maximizing the speed. We want to know the maximum speed. So remember your candidates. I have a closed interval, so I have to include my endpoints of 0 and 4. I also have to include this critical point of 2. So there's my list of candidates that where my maximum speed could occur. So now remember, I want to know what the absolute maximum speed is. So I want to take my candidates and plug it back into my speed function, which remember is the absolute value of the velocity function. And that's why I kind of boxed that speed function up here in the beginning. So I know exactly where to plug it in. Well, what happens when I plug 0 in for t? I plug 0 in for t, I'm going to end up with a what? 0. So when I plug 2 in, that's going to give me, let's see, 400 divided by, let's see, 2 squared is 4. That's going to be a 16 squared on the bottom. That gives me about a 1.5625. When I plug 4 back into my speed function for t, I end up with, let's see, 200 times 4 is 800 divided by, let's see, 16 plus 12 squared. 1.0204. All right. So then where is my maximum speed occurring? My maximum speed is occurring at t is equal to what? 2. So then I know my maximum speed is 1.5625 feet per second. And it's occurring at t is equal to 2. So any questions on how you maximize or minimize speed? Yes, Dan?
Well, do we need to show any specific justification, or if we can just look at it and tell, can we just write that without justification?
You're always going to be doing justification, so.
Right, but if it's linear, if the speed function is linear, then you can just look at it. You don't have to do anything.
Depends on what the directions say.
Okay.
If they say justify, then you have to justify. Okay. Any other questions on that one? All right. So then let's see. Last two parts. Part B. When during the time interval 0 to 4 is the particle farthest from the origin? Well, farthest, we're talking about maximizing what? We're talking about maximizing a distance. So what function are we trying to maximize? We got 3 choices. Well, actually 4. Position, speed, acceleration, or velocity. Position. So we're trying to maximize the position function. So we're trying to maximize S of t. So I have a closed interval from 0 to 4. So I know my possible candidates are going to be 0 and 4. So I know I'm going to have to do And again, I'm trying to maximize position, so I'm going to have to take those values and plug them back into the position function. The question is, to find the maximum, since I want to maximize position, I have to know where S prime of t is equal to 0, which is your velocity function, which again, remember, is the function negative 200t over t squared plus 12 to the second. And I need to set that equal to 0. So what's the critical value coming from the position function then? The derivative of the position, 0, which I already have as one of my candidates. So then what I want to do is I want to take these t values and plug them back into my original function, plug them back into my position function. So when I take 0 and plug it back into my position function, I end up with 100 over 0 squared plus 12. So 100 divided by 12 gives me 8.33. When I take 4 and plug it back into my position function, that's going to give me a 4 squared plus 12 in the bottom. 28. That gives me 3.571. So you can see from my candidates, at t is equal to 0, that's where my absolute maximum is going to be. That's where the particle is furthest from the origin. So then make sure you answer the questions. Part B is when. So what's my answer going to be, 0 or 8.333? 0. So at t is equal to 0. The particle is furthest from the origin. And then for part C, it's asking you what is the position at that instant. So what is the position at that instant? 8.33. And the units are feet. Okay. So any questions on the velocity, speed, etc.?